And I'm back. So 51 and 52 are just like the previous two problems. We will subtract our 4 and we'll get a different number here this time. Actually, this one's easier than the last two. We'll get a 12. We'll divide our 4 out, and this is why it's easier, because 12 divided by 4 is 3. When you counteract your squaring, you'd have x minus 2 equals plus or minus the root of 3, which doesn't simplify. It's as simple as it gets. So we just need to add our 2. We'll have 2 plus or minus a root 3, which means that x is 2 plus a root of 3, or x is 2 minus a root of 3. So that one was pretty easy. 52 looks easy, doesn't it? It ought to be. I don't know if the radical needs simplification or not, but I don't think it will. 18x squared is 72 because 68, add 4 is 72, for those of you that struggle. We're going to divide out the 18. And that should reduce. I think it does. Isn't 72 divisible by 9? I feel like it is. Isn't it 8? Pretty sure it is. Yeah. So we'd have an 8 over, and 18 is divisible by 9. It's 4, isn't it? I'm an idiot. Of course it's 4. 4 times 10 is 40. 4 times 8 is 32. 72. So x is plus or minus 2. Apparently I hadn't woke up yet. Ta-da! 53. Simplify the given number. Since you're not solving for x squared or whatever, there's no need for a plus or minus symbol. You're just doing radical simplification, that's it. To get to 192, it's probably divisible by 16. It's probably divisible by something more than 16, but 16 is a good place to start. I'm just pulling up a calculator to show you. What you do is you find factors of a number. Yeah, it's 16 times 12. Now, 12 is actually 4 times 3. So it turns out that 192 is divisible by 64 3 times. There's my factor. Factors. The root of 192 is a 64 times a 3. The root of 64 is 8, so 8 root 3. 54 is a fraction. What you do is you break it into 2 pieces. Root 4 is easy. Denominator is easy. It's 2. Up top, the root of 125 can be thought of as the root of 5 25s. And the root of 25 is 5, so 5 root 5 over 2. 58 is the root of 128. 128 is a 64 times a 2. And the root of 64 again is 8, so 8 root 2. 56 is going to be a little harder. It's going to be quite a bit harder. In order to add 2 fractions together, you have to have at least common denominator, and there's more to it. You can't have radicals in the denominator and so forth. I'm going to work with this thing, and I'm going to rationalize, it's called rationalize the denominator. Because right now it's irrational. So the first thing I'm going to do is I'm going to simplify it. Root 24 is 4 times 6, 2 root 6. The next thing I'm going to do is I'm going to multiply the top and bottom by a root of 6. That's going to give me 4 root 6 over. Now root 6 times root 6 is 6, times 2 is 12. I'm kind of glad it worked out that way, because this reduces down to 1 and 3. Now I can put these things together, because in order to add 2 numbers together, you have to have a common denominator. And the common denominator is 3, so I can literally add them together. 2 plus root 6, sitting pretty over 3. 57 has the same issue. Somebody a long time ago said no radicals in the denominator. And we fix that on 57 by using the idea of the conjugate. The conjugate of 2 plus a root of 5 is 2 minus a root of 5. So we multiply the numerator and the denominator by 2 take away root 5. Distributive property up top, 6 take away 3 root 5. I'll FOIL it out here in the bottom even though you don't have to. 2 times 2 is 4. 2 times the negative root 5 minus 2 root 5. 2 times a positive root 5 plus 2 root 5. And root 5 times the negative root 5 is minus 5. Ta-da! Almost done. These pieces knock each other out. 4 minus 5 is negative 1. And now I can divide out the negativity into the numerator. Negative 6 plus 3 root 5. Which you would actually see, it actually looks a little better to say 3 root 5 minus 6. That does look better, because nobody really likes to start off with negatives. Always do something positive first, right? 58, 5, take away root 2, sitting pretty over 3 plus root 3. You need to be asking yourself what the conjugate of 3 plus root 3 is, and I guess I should write that out. The conjugate of 3 plus a root 3 is 3 minus a root 3. You change the sign on whatever's weird to form a conjugate. So we multiply the numerator and denominator by 3, take away a root 3. Now this thing is just going to look fugly when it's done. The numerator is going to be horrible. The denominator is going to be a nice number. The numerator is going to be horrible. So if you're asking yourself, do you have to FOIL? Well, yes, you do. You do have to FOIL. 3 times 5 is 15. I don't know why I went that way. 5 times 3 is 15. 5 times negative root 3 minus 5 root 3. Negative 2, root 2 times 3 is negative 3 root 2. And negative root 2 times a negative root 3 is a positive root 6. Those are 4 things. While they're all numbers, they're not quite alike. You can't add them together. They're irrationals, and that's exact form, and I know how kids feel about that, but it is what it is. That's going to give me a 9. Take away 3 root 3. Add 3 root 3. There's your cancellation that you should have been expecting. And then root 3 times root 3 is 3. It's positive times a negative, so it's negative, so minus 3. And let's see what we have here. We have 15 minus 5 root 3 minus 3 root 2 plus root 6, sitting pretty over a 6. And it's done. That's as good as it gets, unless you want to break the fraction apart. But I don't know why you would. So, stop there. Don't be the kid, by the way, who thinks that you can do some simplification here. You can if you break it apart. If you break it apart, you could reduce 15 over 6. If you break it apart, you could reduce negative 3 root 2 over 6. You can't do anything with root 6 and 6 because that 6 is stuck in a radical. So there is your homework. I hope you enjoy doing it as much as I do.